Alright guys, welcome back to our online lessons, and today we're going to be dealing with dimensional analysis. So the previous video that I put up was on significant figures, and while significant figures tend to give issues to a lot of students, dimensional analysis is really one of the most heavily requested things in terms of explanation or further explanation. So what a dimensional analysis is it's basically a way to convert units from one to another. And we're going to talk about two types really. You have dimensional analysis regarding inter-unit conversion, which is where we're going from one unit to a completely different, and then intra-unit conversion, and we'll talk about that in a second. But you can see at the bottom here that I say set up a canceling table. All right, so we're going to draw that on the next page here. A canceling table is essentially something that looks like this. So the most simple one would look like this. And let's say that I have some amount, we'll just say 2.5 of some unit x. All right? If I have 2.5 units of x, the canceling table here, whatever goes up in this position here is going to be multiplied by 2.5. Whatever comes into the position at the bottom on the denominator here is going to be divided. So regardless of what value gets put in there, my goal is that I want to get rid of x and turn it into some new unit y. Because that's what, if we go back and look, that's what dimensional analysis really is. It's converting from one unit to another unit. So whether we stay with the same base unit, for instance, kilograms to grams, or whether we're going between two completely different units, so kilograms and pounds. The end goal is I want my x's to drop out through division, and I want to obtain some new unit y. Now I do want to mention that sometimes perhaps we start with some unit A and we need to get to some unit D. All right, and we're probably not going to start doing that in this lecture so much, but you will find it more and more as we continue throughout general chemistry. So let's say that I have some unit A and I want to get to unit D. You will start setting up canceling tables sometimes that have multiple pieces. So I'll have 2.5A, and then for every one A, there's a certain amount of B, so let's say there's 3 B's. And then I'll get rid of my B's, so the A's cross out, and then the B's cross out, and for every one B, maybe there's 2 C's. And then I want to get rid of my C, and there's D. So maybe for every 2 C's, there's 5 D's, all right, etc. So then I would take 2.5 times 3 times 2 times 5, and once I take all of that, I would divide that by 2. And if you notice, the A's cancel out, the B's cancel out, and the C's cancel out, and I'm left with D. So this is a way that I can get from A to D, and it's very nice in terms of what you would call chemistry bookkeeping. I'm keeping track of A, B, C, and D, and I can follow along in the pathway in case I make a mistake anywhere. So hopefully everybody understands canceling tables. So I mentioned this a minute ago. We have intra-unit conversion and inter-unit conversion, okay? Intra, whenever you hear intra, it means within. So when we're talking about intra-unit, we're talking about within the same type of unit. So only changes in the value of the prefix before the base unit. So like I was saying before, if I'm going from kilometers or kilometers over to meters, that would be an example of this. If I'm going from nanograms over to milligrams, that's an example of this, because I'm doing grams for each of these. I'm doing meters for each of these. Now if I go to inter-unit conversion changes between the base units. So there's actually a change in the base unit. So here, if I go from inches over to meters, or centimeters, would be more on par with inches, it would be yards and meters. And let's say we could do gallons, and the metric for that would be liters. So I could do gallons to liters. Here, it's not just going between millimeter and centimeter. Now I'm doing inch. I'm going into the imperial or the English measuring system. I'm grabbing something and then I'm converting it into a completely different unit in the metric. So Celsius and Fahrenheit would be another example, where we're taking one unit and converting it to something completely different. All right, so there's a couple of tables here, and then we're going to practice, but I wanted to bring these up. So the two tables, the first is a prefix table. And the prefixes here, there's a couple of them that are very important, and hopefully you should recognize some of these. So the kilo, okay? The kilo or the kilo is 10 to the third of your base unit. So it's a very large unit. It's 1,000 times larger than your base unit. Deci, we don't use quite as often, but it is still prevalent, at least compared to the others. It's 10 to the minus 1. Centi, you should be familiar with that through centimeter or centimeter, and that's 10 to the minus 2. So now we're talking small numbers. 10 to the minus 2 is 0.01, so we're talking about hundredth place. Milli, milliliter, millimeter, milligram, that's a very important one. Micro, 10 to the minus 6, and nano, 10 to the minus 9. And those are really the ones in the middle of this table here. Those are the ones I really want you to try to remember or focus on. They're going to be the ones that come up most often when we're doing chemistry unit conversion. Now, if you look on the right-hand side over here, we have an inter-unit table. And remember, when we're talking inter, we're talking from one base unit to another. So you can see some of them there. We have inch to centimeter, foot to centimeter, or you can start doing meters when you get to foot, yard, etc. Miles, so most places do kilometers per hour. Here we do miles per hour with the English system. Ounces and grams, pounds and grams, or kilograms. So a lot of times with weight, in the health industry, you're dealing with pounds when you're over here, or kilograms when you're somewhere else. You've got the fluid ounces, so you can have ounces like 3 ounces of steak would be a solid material. You can also have fluid ounces in milliliters. And then you can deal with quarts and gallons when you're getting up to liters. Those are the larger liquid measurements. All right. So let's try to practice some of these here. Okay? We're going to start with some intra-unit conversion. So for the intra-unit conversion, the first one we have here is 3.5 grams into kilograms. So what we're going to do is we're going to set up a canceling table. I'm going to say I've got 3.55 grams. And I want grams to cancel out, and I want kilograms for my answer. All right? Now, when I do this, this is an important piece, and we're going to practice this with each one of these, all right? When I'm determining which number goes where, because that's a lot of times where students can get screwed up, but they don't know which number they're putting where. You are always going to give the larger unit the value of 1. So in this case, you got to ask yourself, is a kilogram larger or a gram? Hopefully you know the answer is kilogram. A kilogram is 1,000 grams. So we're going to say that 1 kilogram is equal to 10 to the third, which is the same way as saying 1,000 grams. All right? And if I go back to that table right here, the kilo, 10 to the 3. And that's exactly what's appearing down here, 10 to the 3. Now keep in mind, if I write 1 over, which is what I'm really doing here, 10 to the third, that's the same as saying 10 to the minus third. All right? So that's important to remember when we're dealing with these types of things, because sometimes we're using positive exponents and sometimes we're using negative exponents. So if I were to rewrite this, all right, the grams would drop out, I would get kilograms, and I'd really be doing 3.55 divided by 10 to the third, or 3.55 times 10 to the negative third, because I can rewrite this as 10 to the negative third if I flip it. So what I end up with is 3.55 times 10 to the negative third. And that's also the same as saying 0.00355. Sorry, that last 5 got cut off a little there. All right, so that is the way that you essentially set these up. So the next one, let's try this one. we're going to convert 6.2 meters into millimeters. So what I need to do first, set up my canceling table. I'm going to take 6.2 meters, and which goes where? Hopefully you know I want millimeters, so that's going to go on top. I want to cancel meters, so my meters will go on the bottom. They're canceled. Now again, remember what the rule was. The larger unit is always going to get 1. So which one is the larger unit here? Hopefully you know it's meters. Millimeters are smaller. So notice, if I go back here, milli is 10 to the minus 3. So right in between the kilo and the deci, if you look at the kilo, it's 10 to the third. If you look at the deci, it's 10 to the minus 1. If I were to be at my normal base unit, I would be somewhere right in between those two. It would just be a normal base 10, and I would have my unit. All right? So if I'm looking, the milli, we're going down on the scale here. So milli is a smaller unit compared to the base unit. So the base unit is larger than milli. It gets the 1. So then the question here is for the millimeters, how many millimeters is there in 1 meter? So again, this is where students can sometimes get messed up, okay? 10 to the minus 3 is in reference to the base unit itself. So if I turn around here and I say I have 1 meter, it's saying that 1 meter is equal to 10 to the third millimeters. All right? Another way of saying that is 1 millimeter is equal to 10 to the minus third meters. So again, see how it's meters here? All right? This table gives you the values for everything in the base unit, the notation's base unit. So if I had 1 millimeter, I would want 10 to the minus 3 meters. But I'm dealing with 1 meter. So I really have a lot of small pieces making up that one large piece. All right? So what I would get here is 6.2 times 10 to the third, because the 1 would drop out when I divide. So if I finish that off, I'm going to put the answer down here so I have a little more room. I would get 6.2 times 10 to the third. And the unit on that would be millimeters, because that's what I ended up with. I canceled out the meters here. So hopefully you guys are getting the hang of this. I'm going to go through, see if you can follow me on these other two. All right? So I'm going to set up, I'm going from nanograms to milligrams. So I'm going to start with some value of nanograms, 4.57. And I'm going to end up with milligrams. Cancel my nanograms. So, question is, which one is larger? The larger unit in this case is the milligram. So milligram will get 1. And then what I need to do is I need to figure out the conversion between milligram to nanogram. So I'm going to go back. My milligram, or my milli, is 10 to the minus 3. Nano is 10 to the minus 6. So what's the difference there? It's 10 to the 6. That's what's in between there. So if I go from 10 to the minus third to 10 to the minus 9, it's a power of 10 to the 6 that's making the difference. Again, smaller units, I need a lot of them to make up one large unit. So 10 to the 6. All right? It's 10 to the 6 nanograms for every 1 milligram. So, again, I have the large number on the bottom here. So notice, if I have the large number on the top, like I did here, 10 to the third, okay? If I have the large number on the top, I get a large number as my answer, times 10 to the third. If I have the large number on the bottom, then it's going to be a small answer, times 10 to the negative 3. So if we go back here, this is on the bottom, so it's going to be times 10 to the negative 6. That's what 1 over 10 to the 6 is. Remember, we said 1 over 10 to the x, whatever x is really equal to 10 to the minus x. All right, so that's your scientific notation. So if I were to answer this, the answer I would provide is that I would get 4.5 2.57 times 10 to the negative 6 milligrams. Sorry about that 4. Let me fix that. All right. So that would be my answer, times 10 to the 6 milligrams. And that makes sense. That's a very small number. It's saying 0.0000457 milligrams. Well, a nanogram is much smaller. So it's going to take a lot of nanograms just to make up 1 milligram. So if I only have 4.57 nanograms, that's not a whole lot. So it's going to be a very, very small amount of milligrams. All right, one more. Let's convert 6.12 kiloliters into microliters. All right, so I'm going to do 6.12 KL, and then my KLs I want to cancel, and I'm going to keep the micro symbol is sort of this U-looking shape, all right, but it's got the U extends downwards on both sides, so it's microliter. The kilo, that's sort of a bad K, let's try to fix that there. It should be a smaller, lowercase k. The kilo is what I'm going to cancel out. Hopefully you know that kilo is much larger. All right. Now, when we deal with the units for this, going back here, the units for this, the kilo is 10 to the third, the micro is 10 to the minus 6. So if I go 10 to the third down to base unit, that's a factor of 3. If I go base unit down to milli, that's a factor of 3 at 10 to the minus 3. So we're up to a total of 10 to the 6 as our factor. And if I jump again to micro, that's another 10 to the 3 jumps. So 10 to the 6 and another 10 to the 3 is a total of 10 to the 9th. So there's 10 to the 9th microliters in every 1 kiloliter. The large number's on top, so we're going to get a large answer. The answer would be 6.12 times 10 to the 9th microliters. Just like that. Alright? So hopefully that gives you guys a good idea of the intra unit conversion. Now we're going to do the inter. And I'm bringing this back just for a second so we can look at this. Again, remember, we're going from 1 unit, inch, into centimeters, a completely different base unit. Alright, so let's try these here. We've got 15 inches, and we're going to convert it into centimeters. So, as usual, canceling table, 15 inches. Alright, I want my inches to cancel, so whoops. I want my inches to cancel. So they're going to go down there, and I want my centimeters on top. So now the question is, which one is really larger here? Because it's a little bit easier when you're dealing with the prefixes, but now the question is an inch larger or is a centimeter larger? So let's go back. For every 1 inch, there's 2.54 centimeters. So that means that an inch is larger than a centimeter, because there's 2.54 centimeters for every 1 inch. So that means inch will get the 1. 2.54 for my centimeters. So if you plug that into a calculator and you calculated it, I'll go ahead and let you do that for a second. Hopefully what you end up with is 38.1 centimeters. All right? So now we've converted inches into centimeters. Now, I'd like to make a brief point here and just point out, all right, we have 15 inches and we have 2.54 centimeters. If I was reporting this in significant figures, this would not be the correct answer. All right. First of all, 2.54 and 1 inch, these are exact unit conversions, so they have an infinite number of sig figs. And if you don't know what I'm talking about, go watch the sig fig lecture on significant figures and you'll understand. Okay? But I only have 2 in my 15-inch measurement. So if I only have 2 inches when I'm multiplying and dividing, the rule is I keep the lowest number of sig figs. Well, here I have an infinite number. Here I have 2. So the proper way to report this, and we haven't been minding sig figs the whole way through here, okay? But the proper way to report this would be 2 sig figs. The 1 would drop off, and I'd really report it as 38 centimeters. So hopefully you guys understand the reasoning behind that. Again, if not, I just ask that you go back and you revisit the video lecture on significant figures. So to wrap up here, let's try one more. All right, 429 gallons. So that's a large amount of liquid. 429 gallons. Our metric unit for liquid, hopefully you realize, is liters, and that's what we're putting it into, is liters. Gallon. So again, you have to figure out which one is larger. We go back to our table here. Oh, I'm sorry, I'm doing this. We go back to our table here, and gallon, you see 1 gallon is 3.785 liters. So the gallon is larger. There's 3.785 liters in every 1 gallon. 1 gallon, 3.785 liters. All right. So go ahead and take a second, calculate that. And again, not minding the significant figures, the answer you get should be roughly 1,623.7, and that's liters. Should be the answer. All right? So hopefully this makes sense to you guys. Remember, there's a couple of things here. You always want to set up a canceling table. You always want to determine which the larger unit is, and you're going to assign 1 to the larger unit value. And then the smaller unit value is going to get the larger value. So that seems a little bit weird the way I'm saying that. So what it is if you turn around and you take 2 different values, you need to determine which one is larger, so like milligram or microgram. Milligram's larger, so you assign 1 to that. And then the value that is smaller, so the one that makes up a lot of little pieces, that's the one that you give the larger mathematical number to when you're transforming. Okay? And remember, you always put 1 for the larger one, and then when you're converting and you're doing this stuff, you always want to set it up to cancel. So get your unit that you're starting with on the bottom so they cancel out, and then give the unit you want to come out with on top. Alright? So hopefully this makes sense. Please remember to like the video if it helped. Feel free to leave comments, and I would strongly suggest that you guys subscribe. I will continue to post and update videos as they become available and as we cover things. So thanks a lot for watching, guys.